Okay, we are on number 9. Okay, what is the solution to 3x squared minus 2x plus 4 equals 0? Okay, I'm not even going to give you a chance to do this one because this one does not belong on this practice test. Okay, let me show you. The way we typically solve these is we set up two polynomials multiplied together make this, right? Now the problem with this one, we wanted 3. So one would have to be 3x and the other one would have to be x. And then we want to get something that makes 4 and it's plus, so it's either minus, both minuses or both plus. Now we could do 4 and 1 or 2 and 2. If we do 2 and 2, we'll get a 2x and we'll get a 6x. And 2x and 6x is 8x. We're going to be adding them because it's positive. So they're either both positive or both negative, in which case they're still going to add together. So that won't work. If we do 4 and 1, you're going to end up with 4 and 3, 7x, or 12 and 1, 13. We're not going to come close to minus 2x. So you can't do it this way. To solve a hard one like this, and you can tell by looking at the answers, some of them have this letter I in here. What the heck is that there for? What does I mean? We don't even know what I is. You guys don't even know what an I is. I don't know why they put this problem in here. But you would use something called the quadratic formula, and I wrote that down here. Now, the quadratic formula is a way to solve all of these problems. Can be solved with a quadratic formula. Okay? But if they wanted you to use this formula, they should have given you the formula, but they didn't give it on the list of formulas. So they're expecting you to memorize this? No way. I don't remember this. I have to look it up every time I ever use it. Okay, let me tell you what this refers to. I'll just show you how they use this formula. If you look at this quadratic equation, 3x squared minus 2x plus 4, there's a coefficient in front of the x squared. There's a coefficient in front of the x term, and then there's the number, the last number, the coefficient on the end. So this first one is a, this second one is b, and the third one is c. So if you plug these numbers into this equation, you'll get the answer. So actually, it's a very helpful formula. Okay, minus b. So let's try it out. Minus b. Now b here is minus 2. Don't forget the minus, it's minus 2. So minus 2 is 2. Plus or minus. Now the plus or minus means first we're going to do it with plus, that'll give us one answer. Then we do it with minus, and that'll give us the other answer. Okay, square root of b squared. Again, b is minus 2. If you square that, you get 4. Minus 2 times minus 2 is 4. Minus 4 times a, which is 3, times c, which is 4. And then you're going to divide that by 2a. 2 times 3. Okay? Okay, I'm going to move this a little now and try to solve this. So we got 2 plus or minus the square root of 4 minus this stuff. Now 4 times 3 is 12 times 4 is 48. 4 minus 48. Well, that don't sound like fun, does it? 4 minus 48. Okay, divided by 6. 2 times 3 is 6. So now we got 2 plus or minus the square root. 4 minus 48 is, guess what? Minus 44. One's plus and what's minus, they subtract, but it's backwards, so we have to put a minus in front of it. The minus is bigger, right? And that's divided by 6. Now, what can we do with the square root of 44? Well, 2 plus or minus. Now, we got a little problem here. Square root of a minus number, the square root of 25 is 5 or negative 5. The square root of 9 is 3 or negative 3. You can't square a number and get a a negative number. Because if you use two negative numbers, it becomes positive. If you use two positive, it's positive. So how do you get the square root of negative? I don't know. We don't know. So you know what? They call the square root of negative 1, they call it I. I don't know. It's just an imaginary number. They call it an imaginary number. I times I is negative 1. So you could write this as the square root of negative 1 times 4 times 11 divided by 6. So now we got 2 plus or minus. Now the square root of negative 1 is I. The square root of 4 is 2. So I'm going to make this 2I times the, what's left? The 11. You can take the square root of each part. If they're multiplied, you can do each part. So the square root of negative 1 is I. The square root of 4 is 2. 2 times 2 is 4. Okay? Divided by 6. So let's look at our answers. Does any of them look like that? Okay. You see this is 2 and this is 2 and this is 6. We can divide by 2. And we can divide this by 2. 2 goes into 2, 1. 2 goes into 2, 1. So we just put the I there. Square root of 11 and 2 goes into 6, 3. We divided all that by 2 to reduce it. Now do we see it? 1 plus I times the square root of 11 divided by 3. 1. This doesn't have I, so we don't. Oh, there's an I. 1 plus or minus I times the square root of 13. No, we want the square root of 11. 1 plus 2I, nope. 1 plus I times the square root of 11 divided by 3. There it is. Not easy, right? Not easy at all. And that was if you had the formula. We wasted 7 minutes showing you that problem. What a waste. Okay, they would. If they had that on the test, it's really cheating you because there's no way. That's too hard. Try this one. Pause and do this one. Very simple one. Well, relatively simple compared to that last one. Okay, did you do it? Okay, an artist has all her paintings framed with a 3-inch wide border. 3-inch wide border means 3 inches this way, 3 inches this way, 3 that way, and 3 that way. She has a painting to be framed that is 1 foot by 1.5 feet. What's 1.5 feet? That's 1 1/2 feet, right? If you don't want to do decimal, you can do fraction. Okay, so they even show you the dimension on the outside because they had to add 3 on both sides and they added 3 here. Now, you want the perimeter. Which of the following measurements represents the perimeter of the painting with the borders? The perimeter is all the way around. So you got 3 inches plus 1 1/2 feet plus 3 inches plus 3 inches plus 1 foot plus 3 inches. Well, we're going to do the answer in feet, so let's figure this out in feet. Look at this, 3 inches, 3 inches. How many inches are in a foot? 12, right? 3. Let's just do the inches. 3 plus 3 plus 3 plus 3. What is 3 and 3? 6. And here's another 3 and 3. 6. What's 6 and 6? 12. So all these little pieces add up to 12 inches, which is 1 foot. Then you got another foot here. That's 2 feet. And then you got 1.5. So now you have 3.5 feet, or 3 1/2 feet. But you also got to do it again. So you got 3 1/2 and 3 1/2. 3 and 3 is 6. 1/2 and 1/2 is 1 more. So it's 7 feet. You could do 3.5 plus 3.5. If you put that in your calculator, you would end up with 7. You could do 3.5 times 2. You're still going to end up with 7 feet. Okay, on the bottom, try that one. Okay, the problem with this one is here we have cookies, but here we have dozen cookies. So that's a little tricky, right? It takes 1 bag of chocolate chip cookies to make 72 cookies. How many bags does it take to make 18 dozen cookies? So now we're talking about a dozen. And we want to know how many bags it takes to make 18 dozen cookies. Well, you have to know what a dozen is. What is a dozen? A dozen is 12, like a dozen eggs, right? So let's look at this. 72 cookies. If 12 cookies make a dozen, how many dozens is that? If we know how many dozens one bag is, we can figure out how many bags we need. So how many dozens are in 72? How many 12s are in 72? That's a division problem. 72 divided by 12. That'll tell you how many dozens make up 72. Using your calculator, you got 6 dozen. One bag makes 6 dozen. You want 18 dozen. If one bag is 6 dozen, how many 6s are in 18? How many, even though I did the 18 on the bottom, don't worry, you want to do 6 into 18. How many 6s are 18? What times 6 is 18? 2? No, 2 6s is 12. 3 6s. So if one bag makes 6 dozen, how many bags make 18 dozen? You need 3 of them. Each one makes 6 plus 6 is 12 plus 6 is 18. You need 3 bags. Okay? Try reading this one. Number 12. Each time a coin is flipped, it has a 50% chance of landing on heads and a 50% chance of landing on tails. The coin will be flipped 3 times. What is the probability it will land on tails all 3 times? So let's pretend as long as you get tails, you're still in the game. So you do your first flip. What's the chances you're going to get tails? 1/2. Now, you take your second turn. Of those 1/2 of the time that you get tails, how many times are you going to get tails on the second throw? Again, it'll be half of those. Now you know that 1/2 times 1/2, that's 1/4, 1/4. Only 1/4 of the time you're going to get tail and then tail again. But you have to get tails 3 times. So 1/4 of the time you throw 2 tails, and half of those times you're going to throw another tail. So now you have 1/2 times 1/2 times 1/2. 2 times 2 is 4 times 2 is 8. That's 1/8 of the time you'll get 3 tails. 1/8 of the time you'll get 3 heads. And the rest of the time you'll get a mixture of heads and tails. But we want 1/8. That's the chance you'll throw 3 tails. Try number 13. Let me put it over here. Pause it to do it. An electronics store offers to finance the purchase of any single item with 0 interest for 1 year with a down payment of $60. The rest of the purchase price will be split evenly into 4 quarterly payments. Which of the following equations represents the relationship between the amount, $A, of each quarterly payment and the purchase price, $S, of any item under this offer? What I did when I first did this, I didn't look at the answers. I said, okay, S is the total price. You're going to have to pay first $60. And then you're going to pay a certain amount A for 4 times, 4 quarters. So you're going to add to that 60, you're going to do 4 times $A. So that's what I did first. But then I realized I looked at the answer and they want to know what A is equal to. I said, okay, let's go back and do that again. I could use this, but I'm going to start here. A, how much you pay each quarter? Well, you're going to take the total amount that you pay, which is S. And the first thing you're going to do is you're going to pay 60. So I'm going to subtract 60. Then, the part that's left over, what am I going to do? I'm going to divide that into 4 equal parts. Because I'm going to do each of those, the remaining divided into 4 parts, I'm going to do a part each quarter. So that should give me A. A is equal to S minus 60 over 4. And there it is, the first one. Now you could have done that from this. I could have done that from this. I want A. How do we get A? Well, first I subtract 60 from both sides. I subtract it from both sides. And then to get A, I just divide by 4. And the 4 is divided by 4 becomes 1. A is equal to S minus 60 over 4. See, I could have done it this way and then manipulated to get back to the right answer. Okay, number 14. Try that one. How much time we got? 15 minutes. Okay. Let g of x equal to x squared minus 1. What is the average rate of change of the function from x is 3 to x is 6? Well, let's figure out when x is 3. What is x when x? What is y, g of x, when x is 3? What is it? What is it the function spit out? Okay, 3. 3 squared is 3 times 3 is 9. Minus 1 is 8. So when x is 3, g of x is 8. Okay, that's when x is 3. When x is 6, let's try that one. 6 squared, 6 times 6, 36. Minus 1, 35. Okay? Now, we want to know the average rate of change. So it went from 8 all the way up to 35. How much did it change altogether? Well, you subtract 35 minus 8. That'll tell you how much it changed. It went up 27, right? And how many did x change as y? G of x went up 27. X went from 3 to 6. 6 minus 3 is 3. So we're going to divide it by 3 to see what the average change. The whole change was 27, but it did that over 3 as the x went up 3 times. So the average change is just divide 27 by 3. That comes out to be 9. 9 was the average change, 27 divided by 3. You understand? It started at x went from 3 to 6. So if you looked at it on a graph, x went from 3 to 6, but y went from, what was it, 8 up to 35, like that. So the change was 27 for the y, but you divide it by 3 to give you how much it went each time. The average that it went each time. It didn't go evenly, but the average it went each time. Okay, number 15. Try that one. Which expression gives the distance between points S and point T? So we want this distance here from here to here. How do you find a straight line distance? Well, what you can do, you remember what a right triangle is? A right triangle is a triangle that is perpendicular, has a 90-degree angle. That's a 90-degree angle right there. And the thing about a right triangle is that a squared plus b squared equals c squared. So if I want the distance c, I'm going to take the square root. C is equal to the square root of a squared plus b squared. Because c squared is equal to a squared plus b squared. If you square this and square this, it's this squared. If you just want c, you have to take the square root of a squared plus b squared. Okay, now what is a? 1, 2, 3, 4, 5, 6. So c is equal to the square root of 6 squared plus 1, 2, 3. 3 squared. Can you find that there? Is it there? Right there. B. Okay, moving on. We got a little pie graph here. Sort of a pie graph. It's a circle cut into angles. Melody is making a spinner with a 12-inch diameter for a game. She will divide the following spinner into sections. What is the area in square inches of section C? What's the area of that? Whoa. That's not easy, is it? How do you figure out the area of a piece of pie? What we're going to do is figure out the area of the whole circle first. Then we should be able to get the area of a piece of the circle. So what's the formula for area of a circle? Area is equal to pi times the radius squared. Now, they didn't give us the radius, they gave us the diameter. Remember, the diameter is the line all the way across, and that's 12 inches. But we don't want the diameter, we want the radius. The radius is this little line here, not all the way across. It's half of the diameter. So if the diameter is 12, what's the radius? 6. So the area is equal to pi times 6 squared. What's 6 squared? 6 times 6, 36. Area, I'm going to put the 36 in the front now. 36 pi. That's the area of the whole circle, but we only want a piece. How big a piece is that? Well, if you added up all these degrees, you can add them up with your calculator, but you might already know how many degrees are in a circle. 360. And what piece do we want? 45 degrees. So we're just going to divide to find out what part that is. 45 divided by 360. And when we got that little piece, we're going to multiply it times 36 pi. Because we're taking a piece of the whole pie. Okay, if you divided this, this actually comes out to 1/8, which is 0.125. And if you take 1/8 and multiply times divide it into 36, 8, because it'll be 1/8, so it'll be 36. This is the same as 36 divided by 8 pi, because 45 goes into 36 8 times. And your 8 goes into 36 4 times. 4 point, well, you got 4 left over, and 4/8 is a half. 4.5 pi. You could do this with your calculator, though. Right? You can see 36 and 360. That's going to become 1. That's going to become 10. 45 divided by 10. 4.5 pi. There it is. Okay? Okay. Next page. Almost done for today. We're only going up to number 18. Here we go. A lighting designer created a program for the opening of a stage show. When the show starts, 10 lights are on. I hope you tried this one and got an answer. Every 30 seconds, one more light comes on. If T is time in minutes and L is the number of lights that are on, which function best models the number of lights that are on after T minutes of the stage show? So let's think. How many lights do you start off with? When the show starts, 10 lights are on. So L, which is the amount of lights, is equal to 10 to begin, right? Then every 30 seconds, you turn on a light. And T is minutes. So let's think of 1 minute. In 1 minute, how many more lights did they turn on? Every 30 seconds, that's a half a minute. So in 1 minute, they turned on 1 after 30, and then 1 more when they got to a minute. So they turn on 2. Every minute, they're going to turn on 2 more lights, because they turn on a light every 30 seconds, every half minute. So 2 times the amount of minutes, 10 plus 2t. Now, when you start, t is 0, so you just have 10 lights. After 30 seconds, well, 30 seconds would be 0.5, 1/2, and 1/2 times 2 is 1. So you'd have 10 and 1, 11. After 1 minute, you'd have 2 more lights on, so you'd have 12. You understand how it works? After 2 minutes, you'd have 4 more lights on, you'd have 14. This is the right thing. Can you find it there? It's the same as this one. They just have it backwards. One more, last one. A radio station ordered hats and coffee mugs to give away as prizes. A total of 1,000 of these items were ordered, and 3 times as many coffee mugs were ordered as hats. In which equation does H represent the number of hats ordered? This is simple algebra. You remember how to do your algebra? Try it out. Think of what you're trying to find hats, right? So hats is going to be H. That's hats, right? Let me put hats here. Hats is H. How about mugs? How can we represent mugs with H? It says 3 times as many coffee mugs were ordered as hats. So mugs is equal to what? 3 times as many hats. 3 times H. But we don't have to put the times, we just put 3H. You see this is hats, H, mugs is 3H. If hats is 100, mugs is 3 times 100, 300. You understand how that works, right? Now, we can add the two, the hats and the mugs. H plus 3H equals how many hats? How many items altogether? A total of 1,000. In what equation does H represent the number of hats? So we want to find H. H plus 3H is what? 4H. Because remember, H is 1H. 1 and 3 is 4 H's equal 1,000. How are we going to get H? We want 1H. Well, we'll divide by 4. That means you divide this side by 4. H is equal to 1,000 divided by 4. Is that there? Yep, it's E. It's there. Okay, we will continue in the last part on part C. We will continue and finish our test then. Okay? I hope you're trying them all. The more you try, the better you'll get. That's it for now.